All right, so this is method 2, and method 2 is called dimensional analysis. So this is still using moles to get to grams or atoms or molecules and converting between those 3 types of units. This is actually more useful to know in life because when you convert from seconds to hours, hours to minutes, and things like that, you're basically doing this, but you're doing it in your head. And if you can break it down, right? Maybe like one day you start a construction company and you want to find out how many yards of carpet you need to lay down carpeting. You're using this type of math to figure out how much carpet you need, and so on and so forth. So it's actually pretty useful in life to know this type of method. Right? So let's talk about how this would work. It's basically 3 simple steps: identifying the known ratio both ways, use the inequality, and then multiply. Right? So I'm using the same examples as method 1 just so you get an idea and it's not as confusing. So example 1 says, given 12 grams of aluminum, how many moles do you have? Right? So I'm going to start the same way again, where I know I have 12 grams of aluminum. And then I'm going to draw T-charts where I'm looking for moles, right? Here, I need to find something that connects from grams to moles. And if you remember on your periodic table, aluminum, the molar mass is in the unit 27 grams for every 1 mole. So if I'm trying to get rid of the units grams, G here, 27 grams would go on the bottom and mole would go on top. So if you remember earlier from math and ratios, this is basically like a fraction bar, and this line represents a multiplication symbol. So it's 12 times 1 mole, which is 12, over or divided by 27 grams. If there's nothing here, assume it's just a number 1. So it's 1 times 27 grams, which is still 27 grams. Right, so it would be 12 over 27 moles. If I divide that in my calculator, I get the exact same number, which is 0.44 moles. You just really need to write down units for this method, right? Because now I know that units can cancel out, like 12 grams. Grams are canceling out, so I'm left with unit moles. That's the unit I'm looking for. And that's my final answer. So for example 2, a little bit of a harder problem. So let's say this time I have 100 grams of KMnO4 and I'm looking for the number of molecules in the sample. Molecules. So here, I want to get rid of grams. So I know that I want grams to cancel out. I'm going to write that in my denominator. And I know I can get from grams to moles because all of these units are in grams per mole. MOL, G over MOL. Right, so if I find the molar mass of KMnO4, that would just be 39 plus 55 plus 4 times 16 because I have 4 oxygens, right? So adding all that up, that should give me 158. 158 grams for every 1 mole. So 158, because I want my grams to cancel out, will go in the bottom, 1 mole in the top. And then I need to go from mole, somehow get rid of the moles to get molecules. And I know I can get converts from mole to molecules because 1 mole of anything is 6.02 times 10 to the 23rd. Right? So what I'm going to do, remember, as I'm going straight across, I'm just multiplying. This line means divide. This line right here, you can write it down on the side, like put an arrow. This means divide, right? It's just like fractions, multiplying, multiplying. So I'm multiplying straight across the top from my numerator, and I'm dividing straight across I'm multiplying straight across the bottom for my denominator. So 100 times 1 times 6.02 times 10 to the 23rd. So if I multiply straight across, I should get 602 times 10 to the 23rd divided by 158 grams times 1 molecule. Sorry, not 1 molecule, 1 mole. So 158 grams. Divide these two numbers, and I will get the exact same number as in method 1, which is 3.81 times 10 to the 23rd. And once again, your unit is in molecules because that's what you're looking for. If you notice, I can cross out grams and moles, and then I'm just left with molecules.